Today, Europe is racing to secure critical minerals, with official targets to mine 10% of its strategic raw materials at home, process 40% inside the Union, recycle 25%, and cut dangerous dependency before the decade closes. That sounds like an industrial story. It is not. Under the language of batteries, electric cars, wind turbines, defense systems, artificial intelligence chips, and energy security, a quieter map is appearing. Mines are being pushed toward regions where water is already politically, economically, and physically stretched. The demand for lithium alone is expected to rise 12-fold by 2030 and 21-fold by 2050. But the rocks are not sitting in an empty world. They sit under farms, villages, rivers, aquifers, grazing land, heritage landscapes, and dry seasons that are getting harder to ignore. But that is not the scariest part. The fight may not be decided by geology, investment, or even technology. It may be decided by a permit most people never read: the legal right to take water, move water, lower water, discharge water, and promise that a watershed can survive the pressure. So what does this mineral rush reveal about Europe's future? If the green transition needs more metals, and those metals need water, who decides which system gets protected first? Viewers can like, subscribe, and leave a comment with where they live. Because this story is ultimately about every place where infrastructure meets a drying climate. In northern Portugal, in the Barroso region, the hills do not look like the front line of a continental industrial strategy. They look like pasture, stone walls, small roads, old water channels, villages that have learned to live around slopes, seasons, and animals. The fields are not abstract space on a planning map. They are work, they are memory, they are a system of survival built slowly, over generations, around the assumption that water will arrive, move, soak, return, and be shared. Then the drills arrive, the survey vehicles arrive, the notices arrive. The words arrive before the mine does. Lithium, strategic project, energy transition, autonomy, permitting, public interest. A villager hears those words and may understand the big picture. Europe wants fewer fossil fuels. Europe wants fewer supply chains controlled by distant powers. Europe wants cars, batteries, grids, and weapon systems that cannot be choked off by a crisis. But that same villager also understands another map: the location of the spring, the weak months of summer, the slope where runoff disappears, the well that drops when rain misses its season, the cattle that still need water when Brussels speaks about resilience. So, watershed, on the forest, so pine. Europe is not entering a vacant desert, it is entering lived watersheds. In Spain, around Cáceres and Extremadura. The language changes, but the pressure is similar. The lithium is described as opportunity. The local economy is described as needing investment. The deposit is described as strategic. But the people who live near the proposed projects do not only ask how many tons are underground. They ask where the water will come from, where the waste will go. What happens when the mountain is opened? What happens to tourism? What happens to protected landscapes? What happens when the next drought arrives? In Greece, Portugal, Spain, and other countries on Europe's southern rim, the mineral map overlaps with another map that has been forming for decades. A map of heat, seasonal scarcity, stressed rivers, groundwater pressure, farm demand, tourism peaks, and public water systems that must serve more people precisely when there is less water to serve them. The European Environment Agency has warned that water scarcity affects, on average, about 30% of the European Union's territory and about 1/3 of its population during at least 1/4 of the year. In southern Europe, the pressure becomes even sharper. Around 30% of the population lives in areas with permanent water stress, and up to 70% can be exposed to seasonal summer stress. That is the background hum behind every mine permit in a dry basin. Not panic, arithmetic. If a river basin already has too many claims on too little water in summer, a new industrial user is not just another box in a file. It is another straw in a glass that may already be near the bottom. The official warning is not always phrased as a warning about mining. It comes as a broader diagnosis. Europe's water is under pressure from agriculture, pollution, public supply, energy, industry, tourism, and climate change. The Water Framework Directive, Europe's main law for protecting rivers, lakes, coastal waters, and groundwater, exists because water is not supposed to be treated as a disposable input. It is supposed to be managed so ecosystems and people can continue to function. Yet the same European institutions that defend water resilience are also accelerating the critical minerals supply chain. The contradiction is not simple hypocrisy. It is more troubling than that. It is a collision between two real emergencies. One emergency says Europe must decarbonize fast, electrify transport, build renewable energy, strengthen defense, and reduce dependence on highly concentrated supply chains. The other emergency says Europe's water systems are already under climate stress, and the wrong development in the wrong basin can lock in damage that lasts longer than any political cycle. This is why the story matters far beyond Barroso or Cáceres. A viewer in Paris, Warsaw, Milan, Stockholm, or Bangkok may never see a lithium pit. But they use the systems that make the pit politically possible: the phone battery, the electric bus, the solar storage unit, the power grid, the defense supply chain, the promise that green technology can scale without simply moving damage somewhere else. The people near the mine are not standing outside the transition. They are standing inside the part of the transition that is easiest to ignore. The headline number is not one mine. It is not even one metal. It is the speed at which a whole continent is trying to rebuild its material base. The European Critical Raw Materials Act sets benchmarks for 2030. At least 10% of the European Union's annual needs for strategic raw materials should come from extraction inside the Union, at least 40% from processing inside the Union, and at least 25% from recycling. No more than 65% of any strategic raw material at any relevant stage of processing should come from a single third country. These numbers are not decorative. They are a direct response to fear. Europe learned from the pandemic that supply chains can freeze. It learned from Russian gas that dependency can become a weapon. It learned from rare earths, magnets, batteries, and solar materials that the clean economy still has choke points. The old energy system depended on oil, gas, and coal. The new energy system depends on lithium, nickel, cobalt, manganese, copper, graphite, rare earth elements, boron, tungsten, and other materials most citizens never had to think about. The Commission then moved from target setting to project selection. It approved 47 strategic projects inside the European Union under the Critical Raw Materials Act, spread across 13 member states. Reuters reported that these included extraction, processing, and recycling projects covering 14 of the 17 materials deemed critical for the energy transition and security. 25 involved extraction, 24 involved processing, and 10 involved recycling, with some projects counted across more than one category. 22 involved lithium, 12 involved nickel, 11 involved graphite, 10 involved cobalt, 7 involved manganese. This is the moment when policy stops being a speech and becomes a landscape. A number in Brussels becomes a road cut into a hillside. A target becomes a plant. A supply chain becomes a permit office. A line in an annex becomes a village meeting where people ask whether their water will still be there. The lithium number is especially stark. EU demand for lithium is expected to increase 12 times by 2030 and 21 times by 2050, compared with earlier demand scenarios. Imagine a household that uses 1 bucket a day, then suddenly needs 12 buckets before the decade ends, and 21 later on. The problem is not simply finding more buckets. The problem is where the water comes from, who was already using it, and whether the household has confused supply security with physical availability. Critical minerals have a similar trap. A deposit can exist geologically and still be unavailable socially, legally, hydrologically, or politically. Ore in the ground is not supply. A mine on a map is not production. A strategic project is not a functioning value chain. Between the deposit and the battery sits a chain of permissions, roads, power, waste management, processing, financing, community consent, and water. And water is different from capital. Investors can move money across borders in seconds. Water does not move like that. It sits in a basin. It falls in a season. It recharges underground slowly. It carries pollution downstream. It belongs to ecosystems before it belongs to spreadsheets. This is why the headline number has a hidden second half. Europe is not only trying to increase minerals, it is trying to increase minerals during an era when water is becoming less predictable. The European Environment Agency says climate change is expected to intensify seasonal fluctuations of freshwater availability, and drought events are expected to increase in frequency, intensity, and impact. Even where total annual rainfall does not collapse, the timing can change. More rain can fall in heavy bursts. Less can soak into groundwater. Dry spells can lengthen. Heat can pull moisture from soil and reservoirs. The water that a project assumes in a feasibility study may not be the water a valley has in its hardest summer. That is the part buried beneath the headline. The mine is not competing with an average year. It is competing with the dry quarter. It is competing with the bad sequence. It is competing with the year when farmers already need more irrigation, tourists already push public supply, wildfire risk already strains emergency services, and reservoirs are already being rationed. The shock is not that Europe needs critical minerals. The shock is that the mineral rush is arriving inside basins where the decisive question may be asked in liters, not tons. Here is the turn that changes the entire story. The fight is not really about whether Europe needs lithium, graphite, cobalt, rare earths, copper, or tungsten. It does. The fight is about whether Europe can obtain them without treating water as a secondary detail. In public debate, mines are often reduced to the visible wound, the pit, the trucks, the dust, the blasted rock, the noise. But a mine is also a water machine. It takes water in. It moves water around. It must keep water out of places where workers and equipment need dry ground. It may need water to grind rock into smaller particles. It may need water to separate minerals from waste. It may need water to suppress dust on roads and stockpiles. It must manage water that touches waste rock, tailings, chemicals, and exposed minerals. It must store, treat, discharge, reuse, monitor, and account for water long after the first political ceremony has ended. The overlooked object is not the excavator, it is the permit. A water permit is a small administrative artifact with enormous consequences. It can define how much water may be abstracted from a river, a reservoir, a municipal source, a treatment plant, or an aquifer. It can define what can be discharged, at what quality, and under what monitoring regime. It can decide whether groundwater may be pumped down to keep a pit or underground mine dry. It can decide what baseline data is required before operations begin. It can decide who pays if water quality changes, if a spring weakens, if a stream becomes seasonal, if a tailings facility leaks, if the model was wrong. This is why the debate over the Water Framework Directive matters. The Commission has launched a review and targeted revision of the directive to address regulatory bottlenecks and simplify legislation in order to promote circularity and access to critical raw materials while maintaining high standards for human health and the environment. That sentence carries the whole conflict inside it. One side hears bottlenecks and thinks of delays, investors leaving, dependence on China, slow permitting, strategic vulnerability, and the danger of Europe setting climate targets without the materials to meet them. The other side hears simplification and thinks of weaker safeguards, rushed assessments, communities outmatched by technical documents, and water systems forced to absorb risks after the political urgency has passed. The deeper truth is that both fears have evidence behind them. Permitting can be slow, fragmented, uncertain, and expensive. Bad permitting can also be reckless, opaque, and blind to local hydrology. The problem is not that Europe has rules. The problem is that Europe is about to test whether its rules can distinguish between a project that is truly manageable and a project that only looks manageable because the driest years have not arrived yet. Not all environmental conflicts are equal. A noise complaint can be temporary, a traffic route can be changed, a truck schedule can be adjusted, but groundwater is slower. Aquifers are not easily repaired. Contamination can persist. Springs can disappear quietly. A river can lose ecological function before the public understands what has been lost. Water creates the longest shadow. A mine can close, but the water problem can remain. That is the hidden mechanism. A mineral project does not merely occupy land, it inserts itself into a basin's circulatory system. Imagine a watershed as a body. Rain is the intake. Soil is the tissue. Aquifers are the deep organs. Streams are the veins. Wetlands are the filters. Farms, towns, industries, forests, and ecosystems are all drawing from the same circulation. A mine places a pump, a mill, a waste facility, and a discharge point into that body. If the body is strong, monitored, and not overloaded, it may absorb the intervention. If the body is already dehydrated, the same intervention becomes much more dangerous. That is why the phrase water-stressed matters. It does not mean there is never water. It means the margin is thin. It means existing users already consume a large share of renewable supply. It means the basin may function in a wet year and fail in a dry one. It means the most important number is not the annual total, but the shortage in the critical season. The mine may say it will recycle process water. That can be true and important. Closed-loop systems, dry stacking, tailings dewatering, wastewater reuse, and improved monitoring can reduce impacts. But recycling does not make a mine waterless. Water is lost to evaporation, locked into tailings, carried away in concentrate, used in dust control, or required for treatment. Even a careful project has a water footprint. Even a modern project needs trust. And trust is not created by calling something strategic. Trust is created by showing the baseline, opening the data, funding independent monitoring, preparing for worst-case seasons, and accepting that some basins may be too fragile for certain types of extraction. The central mechanism can be called the mine-water conflict pathway. It begins before the first ton of ore leaves the ground. First comes exploration, with roads, boreholes, land access, early disturbance, and community fear. Then comes environmental assessment, where hydrologists model groundwater, surface water, rainfall, recharge, seasonal flow, pollution pathways, and cumulative impacts. Then comes permitting, where authorities decide whether the predicted impacts are acceptable. Then comes construction, when vegetation is cleared, drainage changes, dust rises, and water systems are built. Then comes operation, when pumps run, crushers grind, water circulates, tailings accumulate, and the mine becomes a constant presence. Then comes closure, when the company must stabilize waste, manage water quality, prevent acid drainage or metal contamination, and prove that the landscape will not become a long-term liability. At every stage, the same question returns. What happens when the model meets the real season? A mine plan may be designed around expected flows. Climate change attacks expectation. A permit may be written around historical data. Climate change weakens the authority of history. A river basin plan may assume that demands can be balanced. New industry can push the balance point. A local resident may be told that impacts will be monitored. But monitoring after damage is not the same as preventing damage. The mechanism becomes clearest when it passes through one person. Picture a farmer in a dry valley. The farm does not need the language of strategic autonomy to survive. It needs water at the right time. If groundwater pumping near a mine lowers the water table by even a small amount, the effect may not appear as disaster on day one. It appears as a pump that runs longer. Then, as a well that becomes unreliable in August. Then, as a field that cannot support the same crop. Then as extra cost. Then as debt. Then as a son or daughter deciding that the village has no future. The water moved from atmosphere to soil, from soil to aquifer, from aquifer to well, from well to income, from income to a family decision. That is what a water permit really touches. Or picture a town that depends on tourism. The mine does not need to poison the river to change the economy. It may only need to alter the image of the place, increase truck traffic, create fear about water quality, and make visitors wonder whether the valley is still what it claimed to be. Or picture an older resident who has never read a hydrogeological report but knows when a spring arrives late. For that person, the danger is not measured first in parts per million. It is measured in the loss of confidence that the place still behaves as it used to. This is why the phrase, "not in my backyard," is too small for this story. A backyard is private, a watershed is shared. The people resisting projects are sometimes defending property, sometimes defending identity, sometimes defending ecosystems, sometimes defending water, and sometimes defending the right to be treated as more than an obstacle between Europe and its battery supply chain. The historical layer shows why this conflict cannot be dismissed as imagination. In Portugal's Barroso region, the proposed lithium project has become one of Europe's most important tests of whether the green transition can win consent in rural communities. Reuters reported that a United Nations Aarhus Convention Compliance Committee concluded Portugal had breached an international treaty by preventing the public from accessing key information during the environmental licensing process for the project. The committee said citizens' rights to environmental information and participation had not been fully respected. Portugal's environmental agency disputed the interpretation and said it had acted according to the law. Savannah Resources, the company behind the project, has described Barroso as Europe's largest spodumene lithium deposit, with large estimated resources and ambitions to supply the electric vehicle sector. Then, in another development, environmental groups and local residents filed a lawsuit against the European Commission over the decision to grant preferential strategic status to the Barroso project under the Critical Raw Materials Act. The point is not that this proves every allegation against the mine. It does not. The point is that the permitting process itself has become part of the impact. When people believe information was withheld, when they believe documents arrived too late, when they believe the decision was already politically favored before the community could meaningfully respond, the project loses legitimacy before it starts. And legitimacy matters because mining is not a short visit. It is a long relationship with a place. In a high-trust system, a community may accept disturbance if it believes the benefits are real, the safeguards are enforceable, and the institutions are honest. In a low-trust system, even accurate technical claims are heard as salesmanship. Barroso is therefore not just a lithium story, it is a governance story. It asks whether Europe can accelerate without cutting the social and legal roots that make acceleration durable. There are other precedents beyond Europe. The lithium triangle in South America has become a warning image in global debates because lithium brine extraction in arid salt flats has raised concerns about water depletion, salinization, indigenous rights, and ecosystem stress. The geology differs from hard rock lithium in Europe. The methods differ, the legal systems differ. It would be wrong to pretend the situations are identical, but the lesson travels. When a mineral critical to clean technology is found in a water-limited place, the moral simplicity of the green transition disappears. A battery can reduce emissions and still have a water conflict upstream. A solar panel can be part of decarbonization and still depend on minerals with local impacts. A wind turbine can help move away from fossil fuels and still require rare earths, copper, steel, and concrete that come from real places. The world is not choosing between dirty and clean in a single step. It is choosing between systems with different footprints, different risks, and different time horizons. Fossil fuels remain the main driver of climate change and must be phased down rapidly. But replacing combustion with electrification does not eliminate material politics. It moves part of the struggle from the smokestack to the mine, from the refinery to the watershed, from the oil field to the permit hearing. Europe's own history with mining also matters. Many communities remember older mines that left polluted streams, abandoned waste, scarred hillsides, and promises that did not age well. Modern regulation is stronger. Modern technology is better. And not every mining company behaves like the worst examples of the past. But memory, is a form of data. Communities have learned that once extraction begins, the benefits may leave faster than the damage. Jobs can be fewer than promised. Skilled workers can be imported. Profits can move through corporate structures. The waste stays. The road stays. The altered water stays. This is why the official phrase sustainable mining has to work harder than other phrases. It is not enough to say it. It has to be demonstrated in the exact basin where the project wants permission. The same mine design can be acceptable in one place and reckless in another. The same water use can be minor in a wet basin and explosive in a dry one. The same discharge limit can be protective in a large river and inadequate in a small seasonal stream. The same promise of recycling can be credible if data is public and enforcement is strong, or meaningless if it rests only on company assurances. The vulnerability layer is where the story becomes human and infrastructural. The weakest point is often not the mine gate. It is a small component that does not look strategic until it fails. A village well, a spring channel, a municipal treatment plant, a tailings dam, a road used by both trucks and emergency vehicles, a small reservoir already serving farmers and households, a monitoring station that reports too slowly, a local authority without enough hydrologists to challenge a 1,000-page technical assessment, a public meeting held after the important design choices have already been made. These are the parts where a system can crack. Water conflict rarely arrives as a cinematic flood. It arrives as delay, doubt, paperwork, uneven power, and cumulative loss. A farmer cannot prove a trend until years have passed. A community cannot easily hire the same experts as a mining company. A mayor may want jobs, but fear responsibility for water supply. A regional authority may want investment, but lack the staff to audit complex groundwater models. A national government may want strategic autonomy, but not want to admit that some projects will be politically impossible. The most vulnerable communities are often those asked to carry a burden for a benefit framed at continental scale. A village is told it is helping Europe decarbonize, but the village may not get cheaper cars, cheaper power, or a secure future. It may get noise, trucks, land pressure, anxiety, and a new competition for water. This does not mean the village automatically has the right to veto every project. It means the burden of proof cannot be shifted onto those with the least power. If Europe wants minerals from dry regions, Europe must prove basin by basin that the extraction will not quietly transfer climate risk onto rural people. The problem is even larger because water scarcity does not affect all users equally. A large industrial project may have lawyers, engineers, insurance, political access, and long-term contracts. A small farmer has weather, debt, and a pump. A tourism business has reputation. A household has trust in the tap. An ecosystem has no negotiating table at all. When water becomes scarce, power decides who adapts first. The mine may say it can pay more for water, treat wastewater, build infrastructure, or import supply. But if that infrastructure changes allocation, if it increases energy use, if it draws from public systems, if it depends on wastewater that farmers also hope to reuse, then the conflict has only moved. Europe's water resilience strategy speaks about improving water efficiency by at least 10% by 2030, reducing leaks, modernizing infrastructure, and building a water-smart economy. That is important. But efficiency gains can be swallowed by new demand if every sector assumes the saved water is available for its own expansion. A basin can become more efficient and still more stressed. This is called the rebound danger of water policy. Saving water in one place does not automatically create ecological recovery if new users immediately claim the savings. The mine therefore enters not only a physical watershed, but an allocation politics. Who gets the water saved by repairing leaks? Who gets treated wastewater? Who gets priority in drought? Does the river itself get a protected flow? Does groundwater recharge count as a user? Does a future generation have a claim? These are not philosophical questions when a permit is signed. They are operational questions. A water permit is a moral document disguised as administration. It says whose risk is acceptable. It says whose evidence counts. It says how much uncertainty a community must live with. One of the most dangerous weaknesses is the baseline. Before a mine operates, authorities need to know what the water system already does. How does the aquifer respond after wet winters? How low does the stream fall in a dry summer? Which springs are connected to which fractures? What is the natural chemistry of the groundwater? How does rainfall become recharge? What happens during a drought sequence lasting more than 1 year? Without a strong baseline, every later argument becomes a fog. The company can say the change is natural. The community can say the mine caused it. The regulator may not have enough data to decide. That uncertainty protects the powerful. It is cheaper to argue over causation after damage than to establish a clear baseline before permission. The same is true for cumulative impacts. One mine may be manageable. A mine plus a processing plant, plus new roads, plus more water demand from agriculture, plus climate drying, plus tourism peaks, may not be. Permits often assess projects individually, but water experiences them together. A river does not care which sector filed which application. It only feels the total extraction, the total pollution, the total heat, the total loss of recharge, the total pressure. That is the system danger. Europe could approve projects one by one, each described as acceptable, and still create basin-scale stress that no single permit fully owns. This is why strategic planning has to be geographic, not only industrial. A list of strategic materials is not enough. A list of strategic projects is not enough. Europe needs strategic watersheds, places where extraction may be compatible, places where it requires stricter conditions, places where processing should be located away from scarce basins, places where recycling should be prioritized, places where no amount of strategic language should override water limits. The system layer begins with a paradox. The Critical Raw Materials Act is meant to reduce vulnerability, yet if implemented badly, it could create new vulnerabilities inside Europe itself. The old vulnerability was dependence on external suppliers. The new vulnerability could be dependence on fragile local consent, contested water permits, court battles, and projects stalled because the public believes the process is unfair. A mine that cannot win legitimacy is not secure supply. It is a permanent conflict zone. A project delayed by mistrust may be just as unavailable as a deposit controlled by a foreign power. Strategic autonomy cannot be built against communities. It has to be built with credible rules, transparent data, and a willingness to say no. The European Court of Auditors has warned that permitting remains a bottleneck for critical raw materials projects, and the Commission has tried to make permitting more predictable. Industry groups argue that unclear application of the Water Framework Directive can delay projects and create uncertainty. Environmental organizations argue that weakening the directive would sacrifice water resilience precisely when climate change makes protection more important. This is the narrow corridor Europe must walk. Too slow, and the continent risks setting climate and industrial targets it cannot materially support. Too fast, and it risks repeating the extractive mistakes that created public resistance in the first place. The phrase, new baseline, matters here. Europe's climate is not stationary. The old assumption that drought is an occasional exception is weakening. In many regions, the dry season is becoming a more decisive part of planning than the annual average. Water managers increasingly have to think in terms of extremes, not norms. The new baseline may be a world where every major industrial project must prove not only that it can operate in an average year, but that it can shut down, reduce. It may be a world where water permits are dynamic rather than static, tightening automatically when aquifers drop or rivers fall. It may be a world where mines in water-stressed basins must use independent, real-time monitoring accessible to the public. It may be a world where waste storage is designed not just for past rainfall patterns, but for future extremes, longer dry periods that crack surfaces, sudden storms that overwhelm containment, heat that increases evaporation, and floods that move contaminants. Climate change does not only mean less water. Sometimes it means too much water arriving too fast. A mine in a dry region can still face violent rainfall, tailings facilities, waste rock piles, drainage channels, and sediment ponds must be designed for both drought and flood. That is the new engineering burden. The system must handle absence and excess. A dry basin is not safe from flood. A mine built for the old climate may be under-designed for the new one. Europe's broader water crisis shows why this cannot be treated as a niche mining issue. EEA reporting says only 37% of Europe's surface water bodies reached good or high ecological status in 2021, and only 29% reached good chemical status. Groundwater is often in better quantitative condition, but it remains essential for drinking water, wetlands, rivers, and drought resilience. If water bodies are already failing ecological and chemical goals, adding new industrial pressure requires exceptional care. Again, this does not mean no mining. It means the default cannot be optimism. The default must be proof. Proof that water demand is minimized. Proof that alternatives were considered. Proof that processing does not have to be placed in the most stressed basin. Proof that local users will not lose access. Proof that closure costs are funded. Proof that monitoring is independent. Proof that the public can understand the data. Proof that climate projections, not just historical averages, shape the permit. The system alternative is not simply more recycling, though recycling is crucial. The Critical Raw Materials Act includes a recycling target because Europe knows that primary extraction alone cannot be the answer. But recycling has timing limits. The batteries and machines built today may not return as waste streams for years. Scrap collection, sorting, chemistry, processing capacity, and economics all take time. Recycling can reduce future mining pressure, but it cannot instantly supply the first wave of deployment. Demand reduction also matters. Smaller batteries, more public transport, longer-lasting products, repair, reuse, battery chemistry shifts, better material efficiency, and smarter grids can reduce the total volume of new extraction. This is the most uncomfortable part of the mineral debate because it asks not only where supply comes from, but how much demand society chooses to create. A world that electrifies every oversized private vehicle requires more lithium than a world that also invests in rail, buses, cycling, shared mobility, compact cities, and smaller cars. A grid that overbuilds storage without efficiency uses more materials than one that reduces waste and manages demand. Critical mineral policy is therefore not just mining policy. It is transport policy, urban policy, product policy, defense policy, digital policy, and water policy. The dry region sees the connection first, because it is where the material appetite touches a physical limit. There is also a technological branch. Some mining and processing methods can reduce water use. Dry processing may work for some ores. Tailings dewatering can recover process water and reduce risk. Closed-loop systems can lower withdrawals. Wastewater reuse can reduce pressure on fresh water. Direct lithium extraction may reduce some impacts in brine contexts, though it has its own technical and energy challenges and is not a universal solution. Better ore characterization can reduce unnecessary processing. Real-time sensors can detect water quality changes earlier. None of these technologies should be dismissed, but technology cannot replace governance. A closed-loop claim without public data is just a claim. A monitoring system controlled by the project proponent without independent access does not create trust. A mitigation plan without enforcement is a brochure. The future of sustainable mining depends less on slogans than on whether the smallest failure points are controlled before they fail. The mine-water conflict pathway must be interrupted early. That means using basin-scale water accounting before project approval, not after. It means requiring drought contingency plans that specify when operations must reduce water use. It means giving communities access to independent technical advice. It means making baseline data public in usable formats. It means requiring financial guarantees for closure and water treatment. It means separating political enthusiasm for strategic materials from scientific judgment about local water limits. It means acknowledging that some deposits may remain undeveloped not because Europe does not need the metal, but because the water cost is too high. That is a hard sentence for policymakers. It is also the difference between strategy and panic. Panic says extract wherever there is ore because the deadline is close. Strategy says the transition must not destroy the resilience it claims to build. The section of truth and falsehood is essential because this topic is easy to distort. It is true that Europe needs critical minerals for decarbonization, electrification, defense, and digital infrastructure. It is true that many supply chains are dangerously concentrated. It is true that China dominates important stages of rare earth refining and battery material processing. It is true that relying entirely on imports can create geopolitical vulnerability and hidden environmental harm elsewhere. It is also true that mining uses water, can pollute water, can alter groundwater, and can create long-term waste risks. It is true that some EU strategic projects are located in regions that already face water stress or drying trends. It is true that official water data shows Southern Europe faces serious seasonal scarcity. It is true that public participation and access to information are not decorative rights. They are safeguards against bad decisions. But several claims should be rejected. It is not true that every mine automatically destroys a watershed. The impacts depend on geology, design, water source, processing method, waste management, regulation, climate, monitoring, and enforcement. It is not true that electric vehicles directly cause every water conflict near a lithium project. Electric vehicle demand is one driver, but critical minerals also serve grids, electronics, defense, industry, and storage. It is not true that every drought near a proposed mine can be blamed on that mine, especially if it has not begun operating. Climate change, agriculture, urban use, tourism, leakage, and natural variability all matter. It is not true that opposing a local mine means supporting fossil fuels. A person can support decarbonization and still demand that a project prove it will not damage water. It is not true that calling something green makes it just. It is not true that calling something local makes it sustainable. It is not true that faster permitting automatically means weaker safeguards. But it is also not true that simplification is harmless. The risk depends on what is simplified. Simplifying duplicate paperwork may help. Simplifying away evidence, appeal, baseline monitoring, or public participation would be dangerous. The real risk is more precise. Europe may try to solve an external dependency problem by creating internal water conflicts faster than its institutions can manage them. The real risk is that strategic urgency becomes a political shield. The real risk is that water permitting becomes the place where climate ambition, industrial policy, and rural sacrifice collide. The real risk is not one dramatic catastrophe, though catastrophes are possible. The real risk is normalization. One basin after another, accepting thin margins. One permit after another, relying on optimistic models. One community after another, told that resistance is irrational. One dry season after another, revealing that the old assumptions no longer hold. This is how systems fail quietly. Not with a single announcement, but with a series of exceptions that become the new rule. The future depends on whether Europe can learn to ask the water question first. Before the ribbon cutting, before the subsidy, before the strategic label, before the investor presentation, before the press release, there should be a basin question. What does this watershed have left to give in the hardest season, under the climate that is coming, after existing users and ecosystems are protected? If the answer is unclear, the project is not ready. If the answer depends on hiding data, the project is not legitimate. If the answer assumes away drought, the project is not strategic. If the answer requires a community to trust institutions that have not earned trust, the conflict has already begun. Europe's mineral rush is often described as a race against time, but races can make people look only at the finish line. Water forces a different view. A watershed is not a track. It is a living budget. It can be overdrawn. It can be damaged. It can recover slowly, or not at all. The green transition will need mines, but it also needs limits. It needs the courage to distinguish between extraction that supports resilience and extraction that merely changes the location of sacrifice. It needs to admit that the material foundation of decarbonization is not morally automatic. It has to be built, audited, contested, improved, and sometimes refused. Return to the hills of Barroso. Return to the dry basins of southern Europe. Return to the small well, the channel, the spring, the permit file, the public meeting, the hydrological model, the truck road, the tailings plan, the farmer looking at the sky. The event will not always look like a disaster on camera. There may be no wall of flame, no flood wave, no collapsed bridge. The disaster may be a decision made too quickly in a room far from the basin, or it may be the slow discovery that the water budget was already too tight, and that the new mine did not create the drought, but removed the margin that made drought survivable. That is why this story is haunting. It does not say Europe must choose between climate action and water protection. It says Europe cannot have credible climate action without water protection. It says a transition that ignores watersheds is not yet a transition. It is an extraction plan with better branding. The mineral rush will continue because the demand is real. The question is whether it will continue as a scramble or as a test of maturity. Can Europe build a clean economy without repeating the blind spots of the fossil economy? Can it secure lithium without sacrificing the valleys that hold it? Can it treat rural communities not as obstacles, but as early warning systems? Can it make water permits strong enough to carry the weight now being placed on them? The mines may come. Some may be built responsibly. Some may be stopped. Some may change design. Some may move processing elsewhere. Some may become court cases. Some may become examples of how to do this better. But the lesson has already arrived. The green future is not only measured in tons of lithium, megawatts of wind, or batteries on roads. It is measured in whether the river still flows in August, whether the well still works, whether the data was public, whether the people closest to the risk were heard before the decision became inevitable. This mineral rush will not be judged only by how much metal Europe extracts. It will be judged by what Europe refuses to dry out in order to extract it.